About the slope. Yeah. Yeah, it's all about the slope. Yeah. Oh, goodness, I didn't even see you there. I'm sorry. I was just living the dream singing about slope. Um, anyway, that's what today's all about. How to calculate slope using a graph. All right, here we go. Slope is essentially going to be our measure and our tool to define how a specific line is moving. Okay, the direction in which that line is traveling. Um, what we're going to do is is represent that in a couple of different ways. Um, one way is by the letter m. Another way is saying the change in y over the change in x. Um, but what it does is describe um, how steep or um, how fast a specific set of data is changing. Okay, so the formula. How do we figure out the formula? We first need to kind of understand what slope is. And what it is simply kind of almost like directions um, to how a specific line moves. So there's so many units up and down, and then so many units left and right from two specific points on a line. And the way that we write slope is by writing that up and down movement direction as a fraction over the left and right movement. So, in the most technical way possible, y2 minus y1 over x2 minus x1 is how we would represent a change in y. So the change from one point to another in the y's over the change from one point to the next in the x's, which is also the way that we describe slope, or m, the letter that we use for slope. Um, Basically, it can be found in the simplest way, instead of looking at it more complex with variables and everything, would be by simply counting. It went up 3 and over 5. My slope is 3/5. It could be as simple as that. Um, Looking at a particular graph is always kind of the easiest way that we can find slope. When numbers are involved, then we have to worry about using formulas and everything. So, but for example, if we're looking at example 1, and I want to look at what is the slope of this particular graph, I say it's going up 5, and the up down goes on the top of the fraction, and it's going over 6. Over 6. So what we call this is rise over run. The graph rose 5 units to the next point, and it ran 6 units to the next point. Rise over run. So the slope here is 5/6. How about this one? On this one, the graph rises -3. I mean, it technically doesn't rise at all, it goes down. But the rise is a rise of -3. And the run is 2. It goes over 2. So the slope there is -3/2. Now there's this new thing, which you might have all been thinking while I'm talking, saying, get to it, get to it, get to it. What does this positive negative slope thing mean that's written on the screen here? Positive slope is when we read from left to right and it's increasing. The graph looks like it's going upward from left to right. Negative slope indicates from left to right, the graph decreasing or going downward. So we can see in this case the slope was a positive 5/6. We saw an increase. And in this one, the slope was a -3/2. We saw a decrease. Positive, negative slope. Now, what about when the line is horizontal or vertical? Interesting question. Over here, I would do rise over run. I see that there is no rise, 0, over a run of 7, 0 over 7. In this case over here, I look and I see there is a rise of 4 over a run of 0. Now, the placement of 0 in these two fractions is very, very important. If I have the number 0 and I want to divide 0 into 7 equal parts, it's technically still just 0. However, if I have the number 4 and I want to divide 4 into 0 parts, you kind of get this feeling in your head like, how can I possibly divide something into 0 parts? That can't be possible. And it's not possible. Division by 0 is not possible. We call this slope undefined. We call this slope a slope of 0 because you can split 0 into different parts. It's simply just 0. So this slope equals 0. This slope is undefined. Vertical slope is undefined. Horizontal is 0. Vertical is undefined. Now, what about when there's no graph? I'm just given a table. And, I can rethink this table as xy coordinates. I have the coordinate 1, 8. I have the coordinate 4, 6. The coordinate 7, 4. And the coordinate 10, 2. All written beautifully diagonally. I don't know why that happened. But how do I find the slope given all of this information? Well, I have two options. I could plot them, and I could make a graph if I'm really stuck on that idea. Or I could go back to doing a formulaic way, and I could go to this guy, y2 minus y1 over x2 minus x1, and we can finally learn what that's all about. And I think I want to. So when you're doing it formulaically, you really just need 2 points. Why don't I just choose these two, just for argument's sake? I could use any two. I could use these two. I could use these two. I could use these on the outside. I could use one from the outside and one here. It doesn't matter as long as there's 2 points on the line. So let's take all this mumbo jumbo away. I'm only going to worry about these two. 1, 8, and 4, 6. 1, 8, and 4, 6. 2 points on the line that I have to find the slope for. So what I'm going to do is just label them. First of all, this is an x, and this is a y. This is an x, and this is a y. But in order to determine them and separate them from each other, because I'm going to get confused if I'm saying that this is called x and this is also x, and this is y and this is also y. So I'm going to call this the first x and the first y. I'm going to call this the second x and the second y. x1, y1, x2, y2. The one and the two don't change the number at all. It's just a way for me to recognize which one is which. So now I'm going to go to my formula. It's y2 minus y1 over x2 minus x1. And now these little small numbers here are starting to make a little bit more sense. y2 is a 6 minus y1, which is 8, over x2, which is 4, minus x1, which is 1. What does that give me? 6 minus 8 is negative 2. 4 minus 1 is 3. My slope is negative 2/3. That's what that means. Now, does it matter how I labeled them? Are you thinking to yourself, oh man, what if this was the 2 on this side? What if I made that x2, y2, and this was x1, y1? Would that have mattered? Would that have changed it? Let's try it out. Now, y2 is 8, and y1 is 6. Now x2 is 1, and x1 is 4. So when I evaluate, that's 8 minus 6, which is 2. That's 1 minus 4, which is negative 3. My slope is still negative 2/3. So no, it does not matter which one comes first. All that matters is that you keep clear that these two are the 2's, these two are the 1's. Or these two are the 2's, these two are the 1's. Alrighty? I go up. Lastly, just to review, we have 4 different kinds of slopes that we already looked at. We have positive slope, which rises from left to right. We have negative slope, which falls from left to right. We have a slope of 0, which is a horizontal line. And we have an undefined slope, which is a vertical line. Alrighty. Good luck with the assigned exercises. If you have questions, please remember to write them down. We will talk about them. We'll work through it. And I will see you guys all in class. Have a good one.